Hi, I'm Kim Yuji, a Joint Master and PhD student at Post-Tech. Today, I'm going to introduce CAT3D, create anything in 3D with multi-view diffusion models. So let's start with motivation. Essentially, there are many trials in advancement in 3D creation from 2D images, such as NERP, Instant NGP, and 3D GS. This method greatly improved 3D reconstruction qualities. However, they require a labor-intensive capturing process with 100 to 1,000 outputs. So in this paper, CAT3D tried to change landscape view captures to less exhaustive inputs with generative high-quality novel views. So the less exhaustive inputs means that text, single view, or view. So our goal is to generate 3D, and to generate 3D, we generate some synthetic novel views with given any number of input views. And as I mentioned before, this any number of inputs can be less exhaustive forms such as text and single image. And in other aspects, CAT3D reformulate ill post reconstruction problem as generation problem. So there are many attempts to utilize view generation method for 3D reconstruction, not only for CAT3D. So we are going to look at the previous work and their limitations. First, the prior method simply utilized the pre-trained text-to-image models for 3D reconstruction like Diffusion. They still generated prior of pre-trained models in iterative manners. And they lack precise over the pose of images, which also require the iterative distillation and demand significant time and computational complexity. To overcome the previous limitation, 2D priors with explicit camera conditioning method have proposed. The representative method is 0, 1, 2, 3. They fine-tune the generative models with explicit post conditioning. They show the better controllability of camera pose. However, they are still model or input views independently, so we still require expensive 3D distillation for mitigating the inconsistency between generative views. So modeling the correlations between multiple views can provide strong prior about 3D consistency. So multi-view prior method have been proposed, which model the correlations between multi-views such as 3D self-attention. 3D self-attentions conduct their attention operation not only for the spatial dimension, but with temporal axis between multi-view. And they show better 3D consistent results between generative views, but they work only for the limited scenarios such as object without background. And there are also similar approaches to multi-view priors which directly utilize video diffusion models as priors. Because video diffusion models can generate synchronized video clips with crossover 3D structure, we can adapt it to 3D reconstruction. However, video priors have limited camera trajectories. The previous 3D reconstruction method, which utilize these video diffusion models, are limited on 3D object generation. Otherwise, we want to make 3D on general cases such as 3D scenes, views, or object with background. On the other hand, bit-for-the method without generative prior also has been proposed, and they can output 3D directly without an optimization process, for instance. And they can inference fast because there are no optimization, but the quality is often worse than previous prior-based method. So in the CAT3D, bit-for-the method are included in the comparison. So to summarize the previous work, they have such limitations. They require iterative distillation, which is a significant time complexity, and they have inconsistency between different model views. And they have a limited camera trajectory, which cannot cover the wide range of 3D. And because of the training data set, they cannot generate the various scenarios such as 3D scenes, view, or objects with context. So CAT3D try to overcome these limitations and can get high quality 3D result. So any question at this point? So keep going. So let's dive into the method. Similar to the previous method, CAT3D also utilizes generative priors. And what the difference is that they design the novel multi-view diffusion models and decouple the multi-view generation process and 3D reconstruction process. So with their proposed multi-view models, we can generate a large number of novel views given any number of input views. And this any number of input views is less exhaustive form. Next, they propose robust 3D reconstruction pipeline because our ultimate goal is to generate 3D. This pipeline, we can get the high fidelity 3D models. This design decouples the generative prior to 3D extraction, which means that there is no iterative distillation. So it gives us both computational efficiency and reduction of complexity of method relative to prior work. And as shown below, CAT3D can generate their 3D model within 1 minute. So this is the detailed architecture of a multi-view diffusion model they proposed. So the input is any number of observed views denoted as blue. And the output is a set of target novel views with multi-view consistency denoted as red. They say any number of observed views is input, but the total number of views that multi-view diffusion can take as input is 8. And we can change the observed view and target view, but the sum of them must 8. And next, they inject their camera information according to layer map, which is camera layer information. So to encode the camera conditions, they use this laymat representation, and it has same height and width as the latent. So it encodes the lay origin and direction at each spatial location. So here we compare the previous camera conditioning method and lay map of CAT3D. 0123 is one of the representative methods about camera conditioning generative models. So 0123 use low-dimensional camera pose embedding, which is four dimensions, because they have polar angle, azimuth angle, and radius. They originally have 3 dimensions, but due to the incontinuity of the azimuth angle, they encode their azimuth with this, and the total dimension is 4. Compared to this, CAT3D has more higher dimensional camera pose embedding, whose dimension is height, width, and feature. This height and width is same as latent. And I cannot exactly figure out what is the F, but I guess F is probably 6 because lay origin and direction has 6 dimensions. And if we add the positional encoding to them, it will be more higher dimension. So we get the observed and target view set, and we also get the lay map encoding. So let's inject our input to the multiple diffusion model. So as I mentioned before, we take a set of observed and unobserved views. And the observed view, denoted as blue one, are only used in the spatial temporal joint potential, which is the same as 3D cell potential. And CAT3D only generate the unobserved target views, denoted as red and yellow. So this is the detailed architecture of their multi-view diffusion models. And this architecture is similar to video latent diffusion models denoted LDM. And they replace their time embedding with the camera pose embedding of each image. So the difference with the previous video LDM is that CAT3D uses spatial temporal joint attention, which is the same as 3D self attention here. And 3D self attention compute their attention operation, not only for their spatial dimension, but also to their multi-view axis. And they also propose various camera trajectory which proper to diverse scenario, and they use very diverse data set. So for some images with fit on 3D object reconstruction, they use their orbital camera trajectory as shown in here, A and B. And for some image set which has 3D scene representation, they argue that the view required to full cover the scene, and they propose various camera trajectory like C or G or C. So selecting camera trajectory that fully cover the 3D scene is important for high quality 3D generation result. And they use different trajectory based on characteristics of their different data set. I think it helps CAT3D can generate various background images. And next, our ultimate goal is to reconstruct 3D, so they propose some robust 3D reconstruction method. So this is the second step of CAT3D. So the proposed multi-diffusion models can generate reasonable 3D consistent multi-view, but not perfectly 3D consistent. So they propose robust 3D reconstruction method to mitigate this inconsistency. For robust 3D reconstruction, they modified the standard nerve to improve the robustness to inconsistent views. As a single note, generating perfectly 3D consistent images remains a hard challenging problem, even for the state-of-the-art diffusion model. So robust 3D reconstruction is just simple, which is combined of GNRP and the LPIPS rules. LPIPS rules emphasize the high-level semantic irregularities. It means that they ignore potential inconsistency in low-level frequency details. So they help to mitigate the inconsistencies between generated multi-view with these characteristics. So this is all of the method. So to summarize, CAT3D proposed two-step approach for 3D creation. First is their multiple diffusion models, which can generate large number of novel views with multi-view consistency. The next one is robust 3D reconstruction pipeline that simply combines standard nerve to LPIPS rules, which can mitigate the remaining inconsistency of generated views. So CAT3D overcome the limitation of previous method here. So CAT3D can 3D work with no iterative distillation because they decouple the generation and reconstruction part. And they can generate multiple consistent images with their spatial for 3D self-attention. And they can work on the general diverse scenarios like object themes and objects with some background which previous work cannot work. So this is the all of the method. And is there any questions about method?
That's about Rayman conditioning. Is the Rayman conditioning is first method that proposed in this paper?
Well, I have to check, but I think it's the first time I see this method here. Do you know any method about this? No. So I will check about this. Thank you.
Okay.
Yes.
So Ray origin is defined the word or
You mean the way representation is defined in word coordinate?
Yep.
I think so.
Ray origin. That's by origin.
Also the 3D coordinate. Yeah.
Origin is organized vector. Starting from pixels to values.
Yeah, the direction vector is light, but to represent the radiation, maybe we can use 2 point and A minus B will be direction light. Again. Is it okay? Application. Any questions? 당연합니다.
이렇게 해가지고 이미지를 약 8장 이렇게 생성했잖아요. 그게 처음 보여주신 뭐 양머리처럼 브로콜리에다 양머리처럼 되는 그림을 봤을 때 되게 컨시스턴시하지 않은 이미지들이 제너레이트 것 같아요.
아, 그래요?
봤을 때 나는 플립이 바뀌는 순간이 있죠. 저런 것들을 그냥 바로 옆에다가 바로 이렇게 써서 이렇게 자연스러운 노블 뷰가 나왔다는 것 자체가 그냥 그 저기 파트를 어떻게 저렇게 컨스턴스하지 않은 부분을 내렸는지 잘 이해해요.
좋아요. 일단은 이 상황에서는 인풋이 싱글뷰만 들어가는 거예요. 그래서 보시면은 이 모델이 8개의 뷰를 받는 거예요. 여기서 이 파란색이 이제 저희가 가지고 있는 뷰고, 여기서는 한 개인 거예요. 이 그림에서 3개지만 아까 그 얘기가 한 개인 거고, 그럼 나머지가 이 4개 뷰, 우리가 만들고자 하는 뷰로 들어가는 거예요. 7개. 그래서 여기에 보면은 노이즈로만 그냥 들어가는 거예요. 그래서 이러한 8개의 그 뷰 셋을 이 멀티뷰 디퓨전에다가 태우는데, 여기서 그 주어진 우리가 이미 이미지로 가지고 있는 뷰는 어텐션을 할 때만 사용을 합니다. 그래서 그 제너레이티드 된 결과는 7개의 타겟 뷰에 대해서만 생성이 되는 겁니다. 근데 이제 그 과정에서 말씀하신 것처럼 멀티뷰 컨시스턴시를 주기 위해서 이런 뭔가 하이 레졸루션의 레이맵을 넣고, 그리고 이제 걔네들 사이에서의 그 어텐션을 할 때 본인들의 그 스파셜 하이스트 믹스 내부에서만 어텐션을 하느냐, 그 8개의 뷰가 있으면은 8개의 내부 안에서 본인들끼리 또 이제 뷰 디렉트 여러 개의 뷰 엑시스를 따라서 어텐션을 해줍니다. 그게 이제 3D 컨시스턴시를 늘렸다라고 얘기를 하고 있고, 그리고 좀 디테일 해가지고 얘기 안 하는 것들도 있는데, 얘네가 사실 하나의 뷰로 저렇게 완전한 씬을 만들려면 80개에서 100개 넘어가는 뷰를 사실 생성을 해야 돼요. 널프 학습할 때도 그렇게 많은 뷰가 필요로 하고. 그래서 그런 뷰를 샘플링 하는 것도 뭔가 본인들이 이제 좀 제안한 뭐 케이니스 같은 걸로 뭐 일단은 이제 저런 하나의 노벨뷰가 하나의 우리가 찍은 이미지가 있으면은 얘를 기반으로 7개를 만들 때 최대한 터트려서 만들고, 그러면은 처음에 만든 그거를 앵커로 두고 이제 걔네에서 또 이제 케이니스 클러스터링 같은 걸로 뷰 같은 거를 얘네들의 니어한 것들끼리만 이렇게 뭉쳐서 되게 해요. 그런 식으로 제너레이션을 하면은 그래도 좀 더 멀티뷰 컨시스턴트하게 할 수 있다라고 얘기를 해서, 그런 카메라를 샘플링하는 거에서도 조금 휴리스틱하지만 들어가 있습니다. 혹시 이해가 되셨을까요?
이 컨시스턴시하지 않은데 넓혀를 합성할 때 어떻게 목표가 제대로 만들어지냐는 게 중요해가지고.
그래서 그거를 위해서 이제 죄송해요. 그거를 위해서 이 3D 리컨스트럭션을 제안을 한 건데, 이게 사실 직널프를 그냥 가져다가 쓴 건데 한 페라그램밖에 없거든요. 근데 거기다가 직널프에 원래 LP스가 없었어요. 근데 LP스를 추가한 거예요. 왜냐면 그 LP스가 뭔가 좀 하이 레벨의 정보를 줄 수 있다라고 생각을 했고, 거기서 조금 더 추가적으로 들어가는 게, 처음에는 이제 뭔가 그런 LPS 웨이트의 스케줄링 같은 거 안 해주는데, 사실 우리가 실제로 찍은 이미지에서 가까운 뷰를 만들면 원부보다는 훨씬 컨시스턴트 할 거잖아요. 그래서 그런 거에 대해서도 웨이트를 디스턴스에 따라서 그런 로스 웨이트를 또 주기도 합니다. 그걸로 그냥 3D를 학습한 게 답니다. 3D 부분.
엘트러스 말고 엘픽스를 집어넣어
엔트로피요. LPS에 대해서 자, LPS 피처 땅에서 뽑아서 여기서 엘토 놓는 거 지금 뭐냐고 했어요. 그냥 LPS 가져오는 한데 정확히는 모르겠네요. 저희가 알고 있는 엘픽스인 것 같아요. 제가 생각하기.
논문을 잘 안 나오나 있으니까 일단 순전인 것 같다라고 하셨는데 이거 생각하시네? 이거 포지셔널 인코딩 같은 부분이 들어가야 할 것 같은데 어떻게 들어가는지 제가 잘 이해가 안 돼요. 혹시 설명을 해주실 수 있어요?
사실 이 부분은 온전한 거의 추측이라는 거를 일단 말씀드리고요. 이제 원래는 이렇게 6디멘전인데 포지셔널 인코딩이라는 게 얘네들을 각각 사인 코사인을 태우는데 그 사인 코사인도 한 개만 태우는 게 아니고 약간 그 프리퀀시를 L이라고 두면 L개만큼의 사인 코사인을 태우는 거라서 만약에 요 레이 오리진 하나에 대해서 그 포지셔널 인코딩 저희가 아는 그 사인 코사인을 하면은 이 L만큼 이제 증가를 하거든요. 디멘전이. 그래서 총 6개다가 그 사인 코사인이니까 2 곱하기 그리고 그 프리퀀시 사인의 그 프리퀀시가 얼마나 되는지에 대한 것까지 합친 정도의 디멘전이 될 것 같아요. 시험을 코딩을 했을 경우. How can you know? Maybe we sample, we manually sample the
CAT3D generate the predefined kind.
yeah, it's right. And they also propose some generation for generation sampling for camera 32. They also propose. 넘어갑니다. Yes. And there are experimenters as well. So they use diverse training data set which contains 3D objects and scenes. So, and they add some additional evaluation data set to evaluate their method in out of distribution setting. So they put their in distribution data set and out distribution data set. And later one is more difficult. And for research, they use 16A100 GPU to generate their multi in 5 seconds. So first one is View 3D reconstruction result. And CAT3D outperforms the most baseline approaches across all setting and metrics. So this red one is the best performance. And the upper row are in-domain settings, which are more easier. And the lower rows are out of distribution settings. And this is the qualitative result for 3D reconstruction. And CAT3D show crossover content in unseen regions compared to baseline method, the middle row. Next experiment is single image to 3D. And CAT3D show higher quality for scenes compared to baseline method. The middle one is CAT3D. But on images with segmented object, CAT3D's geometry is opt worse than the existing approaches. However, they show compatible results at Cliff score. And additionally, CAT3D is more than an order of magnitude faster than previous method. And CAT3D compared several multi-view diffusion model variants and show all design component is essential, and this is the ablation study. First, for the target views, jointly modeling multiple outputs, it means multiple novel views, creates more consistent views. And for the camera conditioning, they compare their high-dimensional laid map representation to low-dimensional vectors. And the low-dimensional camera embedding works well for the main setting, but generalized poorly compared to laid map conditioning. So here is in domain and here is subdomain. And for the attention layers, they compare 1D self-attention is temporal attention and the 3D attention. And they show that 3D self-attention is crucial because it shows improved performance. And finally, they select their model with these 32 by 32 pixel maps because the finest one, 64 by 64 maps, incurs a significant computational weight with marginal improvement. And for the initialization, from pre-training weight, improve performance and out-of-domain cases compared to from scratch settings. And they use their pre-training weight about the text to image models, not video. And they show that LP flows is also crucial for achieving high-quality textures and geometry. Here. And they also compared 80 versus 720 generative views to show that, and the latter one improved center object geometry, but introduced background blur here. So it is due to some inconsistency in generative content. So this result showed that perfectly consistent multi-view generation is difficult to achieve. So to conclude, CAT3D is the 3D content creation method from any number of input images. And this any number is some easier one with text or single view or view view. And they propose two-stage approaches. First is the multi-view diffusion model, and the second one is robust 3D reconstruction pipeline. And they decouple their generative prior from 3D extraction, and it shows efficient, simple, and high-quality 3D result. However, they have also some limitations. First, they cannot handle multiple cameras with different intrinsics because of some limited data set. And their generation quality relies on the expressivity distribution for base text to image model. Third, the number of output view is relatively small. We only get input per 8. So large set of samples may not be so consistent as we previously seen. And finally, they propose some heuristic camera trajectories. And it is difficult to design for arbitrarily large scale open and 3D scenes. So that is for my presentation. And is there any questions?
Which of this is they generate whole thing along with a single object. I didn't understand which components enable that property. Which components enable this model to generate the whole thing along with a single object compared to the previous one.
In my opinion, I think they use beyond diverse data set here. Object is for object, and CAT3D is object with background, and your SK is for scene. And I don't know exactly about that, but it is for some video data set. So I think previous method only trained on some observers and some object-centric data set, and I think CAT3D use this diverse data set, and they also utilize some architecture similar to video diffusion models help they can make some of this diverse scene with backup, I think.